Hello everyone, welcome back. Today we are going to discuss a concept and a question based on horizontal projectile motion. Now they have given a question here in which a body is projected horizontally with a velocity u from the top of a tower of height h. Then we are asked to calculate the time taken by the particle to reach the ground, what will be the height of the tower, velocity and the angle made by the velocity with the horizontal at any instant of time. At any instant of time along its path, we are supposed to calculate the velocity as well as its direction with respect to the horizontal. And also we are asked to calculate the velocity with which it will strike the ground. Along with that, we are supposed to calculate what is the angle with which it will strike the ground. These are all the things that we are supposed to calculate here now. So for this question, we basically have to draw the diagram. So I have already drawn the diagram. And remember, I am primarily considering a condition here that whatever the terms that I take along the direction of the motion, I take them to be positive, whether it is here in this case, the motion will be vertically downward as well as and horizontal. So that means whatever I take downward, I take positive. Whatever I take upward, I take, toward the right, I take it positive. Now towards the left, whatever I measure, whether it is velocity or displacement, I take it as negative. Upward, whatever I measure, I take it to be negative. Simple rule. I'll follow a simple rule here. Whatever I take along the direction of the motion of the particle or the body, I take them to be positive. In the question I mentioned, what will be the height of the tower? So this will be the height. This is the height I have to calculate. Along with that, we can calculate the range of the projectile as well, the horizontal projectile. And in the question, they asked you to calculate at any instant the point P is located here. At any instant of time, let the particle or the body be at this point P. At this instant, they are asking you what will be the value of alpha and what will be the value of velocity. We will define this in vector form v bar as vx I cap plus vy j cap. We'll have to calculate vy value as well as vx value in this case. And one more thing is, at the point of striking, this is the point of striking, this is point P, the point Q, which is where the body is striking the ground. So at this point, you are supposed to calculate the velocity v, or I've taken the velocity at this point as v dash. So this v dash value you have to calculate. Along with that, what will be the angle with which it will strike the ground, which is theta we have considered, with which the body will be striking with respect to the horizontal. It will be striking with what angle? Theta. And also, even we can calculate what will be the inclination to the point of projection. The inclination beta also can be calculated here. And remember, for the horizontal projectile motion, one basic rule. What is that? The component of velocity along the horizontal always remains the same, because in the horizontal projection, this is the initial velocity of projection, which you can consider it as ux, which is equal to u. This component of velocity remains at any point you take. Whether the point be here, the horizontal component of velocity is u. Here it will be u. At any point of the particle's path, its velocity will be u only. But what changes here is the vertical component of the velocity. Because of the effect of gravity, the velocity, the vertical component of velocity goes on increasing from 0 to this value here v, which is vy dash. So this vy dash will be how much we have to calculate. And also we are asked to calculate the time taken for the particle to reach from the point O to the point Q. That is nothing other than time of descent, we call it. Also we can write it as total time taken for it to reach, which is time of flight in the case of horizontal projectile motion, which is nothing other than the time of descent. Now here, if you are supposed to calculate the time of flight is what you are supposed to calculate. In that case, for calculation of the time of flight, we will take the equations of motion. So if you consider time of flight or time of descent, the first condition, which is first question A, for calculation of time of flight or time of descent, time of flight, if I have to calculate time of flight, which I take it as capital T, the total time taken for the particle to reach the point Q from the point of projection. I use this equation of motion using S is equal to ut plus half at square, but it is for the vertical displacement. So what I'll take it is Sy is equal to uy into t plus half into ay into t square. So here what will I substitute is, here I take Sy is equal to height of the tower, which is h, uy is equal to initial vertical component of velocity, which will be 0, ay is equal to g, and t is equal to capital T I consider it. Substituting these values, what I'll get here is, I'll get h is equal to half g capital T square, from which I can calculate the time of flight t as root of 2h by g. Root of 2h by g. This will be the time of flight. Time of flight. If you observe here, this time of flight is independent of velocity of projection. Velocity of projection. And remember, here itself we can take the calculate the height. Height can be written as equal to half gt square. You can write. We can write it as half gt square itself. So simply write it down as, if you know the time of flight or the height of the tower will be given. So h also can be written as half gt square. Half gt square. So this will be the time of flight or time of descent we can consider as. The next thing they're asking, next thing we can calculate here is, under this only I will calculate it. This height is nothing other than the vertical displacement. Height of the tower is nothing other than the vertical displacement that is traveled by the particle from the point O. That means the horizontal displacement is nothing other than the range of the projectile. This horizontal displacement, whatever we are talking about, is what we call it as the range of the projectile. This range of the projectile is the one which is horizontal displacement. Why is this? What is this velocity causing the horizontal displacement? The horizontal component of velocity. So in that case, I can take the range of the projectile as range of the projectile calculated as r is equal to the horizontal component of velocity, which is ux, into the total time taken, which is time of flight. So in that case, range r is equal to, I'll get it as ux is u into time of flight is root over 2h by g. This will become the range of the projectile. This will become the range of the projectile. Here the range of the projectile now is going to become r is equal to u into root of 2h by g. This is the condition. Now what else is the asked to us calculate? We can calculate the velocity of the projectile at any instant of time. To calculate the velocity of the projectile at any instant. Question B is height of the tower over, and the velocity and angle made. Question C we have to do it. Now question C is velocity of the particle at any instant of time. I consider the velocity at any instant t as v bar is equal to Vx I cap plus Vy j cap. Now at this point P is where I am considering that at a time t seconds, the point P is where the particle is located. At this point P, the velocity is given by so much. This is the velocity vector V, or V bar you can write it as. So it is making an angle alpha with the horizontal. That means this component will be the x component. This will be the y component of the velocity. I already told you the x component of velocity will always remain constant, which is equal to u. But what we are supposed to calculate now? We are supposed to calculate the y component of the velocity. We are supposed to calculate the y component of the velocity. So here in this case, x component of velocity can be written as Vx. X component of velocity Vx is equal to, which generally if you are provided with the alpha value and V value, then you can write it as V cos alpha, which is generally equal to u. Which is equal to u. But we are supposed to calculate Vy, which is equal to V sin alpha, which is to be calculated. For this, what I do is, I'll use equation of motion, which is using Vy is equal to Uy plus Ay into t. So in which Vy is to be calculated, Uy is vertical component of initial velocity, which is 0. Ay is equal to g. In that case, Vy value will be equal to g into t. So I know the Vy value now. So in substituting in the above equation of velocity, what will I get? I'll get V bar is equal to Vx is Ui cap plus Vy is Gt j cap. This is the velocity vector at any instant of time t seconds. At any instant t. Now what is the magnitude of this velocity? Magnitude of this velocity is to be calculated. Magnitude of V bar is, we can write it as V bar, modulus of V bar is equal to V, also we can write as, which is equal to root over Vx square plus Vy square plus 2Vx Vy cos theta we will take, but theta will be 90 degrees, so it will get cancelled out. So this is the value. So what will be the velocity magnitude? Equal to root over u square plus g square t square. At any instant of time, the magnitude of the velocity will be equal to root over u square plus g square t square. Next, you are also supposed to calculate the angle at this point. So angle, if I am supposed to calculate at this point, what I can clearly take is, if this is alpha, which is the angle made by the velocity vector with respect to the horizontal, that means, can I take a very simple way, tan alpha here, because tan alpha is nothing other than opposite by adjacent. I know the opposite side, I know the adjacent side. Here opposite side is nothing other than, opposite side is equal to what we got it as, V sin alpha, we got it as gt. So I know opposite, I know adjacent, so I just take it as tan alpha, the direction of the result of the vector at any instant. Tan alpha is equal to, we can write it as tan alpha is equal to, I can take it as Vy divided by Vx. So from which I can write tan alpha is equal to, Vy is gt and Vx is u, so gt by u. So alpha will be equal to tan inverse of gt by u. This is the angle with which angle of the velocity vector at any instant t seconds. This is the velocity and angle. Now the last thing we are supposed to calculate is velocity with which it will strike the ground. So velocity with which it strike the ground, and what will be the angle at that point. So velocity with which it strike the ground, we have considered as v dash bar, which is equal to vx dash bar, vx dash I cap plus Vy dash j cap. See, at the point of striking the ground, I have taken the angle made by the velocity vector with the horizontal as theta. And the x component is v dash x, which is equal to v dash cos theta, which is equal to obviously u, because the horizontal velocity component remains constant at any instant of time. And its vertical component of velocity is vy dash, which is equal to v dash sin theta, which is to be calculated. Here, in that case, to calculate Vy dash, Vx dash value is equal to V dash cos theta, which is equal to, I take it as U, because it will remain always the constant. Or I can take Vy dash value as, Vy dash value is to be calculated. So for that, what I do, using Vy square, Vy dash square minus initial velocity here, which is Uy square, is equal to 2 into Ay into Sy. So in that case, here Vy dash is what is to be calculated. So final velocity, if you consider, initial velocity vertical component is 0, and here acceleration Ay is plus, and Sy is the vertical displacement, which is equal to h. So in that case, what I'll get, the y component here is Vy dash is equal to V dash sin theta, which is equal to, we can calculate here using this equation, what will I get is Vy dash square is equal to, I get it as Uy is 0, so it will become 2gh, or Vy dash is equal to root of 2gh. Even this value can be written in terms of time as Vy dash is equal to root of 2g into h value, we know we already calculated it as half g capital T square. So that means we can also write it as into half g capital T square, from which again I can cancel 2 and 2 here, it will become g square T square. So Vy dash is equal to root of g square T square, which is equal to g into capital T, which is Vy dash value can be equal to g into capital T, or I can also write it as a root of 2gh. G into capital T, T is time of flight here, so we can take it as root of 2gh. I know the value of Vy dash and I know the value of Vx dash, so I can calculate the velocity vector now at the point of striking the ground. V dash bar can be written as Vx is u I cap plus root of 2gh j cap. Magnitude of this velocity is magnitude of velocity vector, which is v dash bar is equal to v dash, which is equal to root over vx dash square plus vy dash square, because they're perpendicular components. Theta is 90 degrees, so it will become 0. So here what I'll get is, I'll get it as u square plus 2gh, or if I take it as gt, v bar can be written as, v dash bar can be written as u I cap plus g capital T j cap. That is, I can write magnitude of the velocity vector as equal to v dash is equal to root over vx square or x dash square plus vy dash square, which is equal to root of u square plus g square capital T square, which is the total time taken for the particle to reach the ground. So this will be the magnitude of velocity. Direction of the velocity vector at that point, direction is given by the theta angle here. The direction is given by the angle theta here. So this theta can be written as tan theta is equal to opposite by adjacent. So this value I got it as, here we can just, I'll replace this value, which is equal to, I can take it as root of 2g into h, or I can also write it as g into capital T. So from which I can calculate the value here, direction, what I can take it is tan of theta is equal to, I get it as h by, sorry, Vy divided by Vx, which is equal to Vy is root of 2gh by Vx is u, or I can also write it as tan theta is equal to, if I know the time of flight provided, g, I can write it as Vy by Vx, which is equal to g capital T by u. So theta, that implies theta will be equal to tan inverse of g capital T by u. Here also I can write it as theta is equal to tan inverse of root of 2gh by u. And here there is one last thing that we can calculate as well in the equation here itself. You can calculate the tan beta value. What will be the tan beta value be equal to? Tan beta will be equal to, here only you can calculate it as opposite by adjacent. So that will be equal to h by r. H by r. You can even elaborate it and write it in terms of the angle of projection. Sorry, angle of striking the ground. How can you write it? So for that, I'll just write it here. We have it as tan beta. Tan beta is equal to height of the tower divided by capital R. Height of the tower you can take, or height from which the body is being horizontally projected also you can consider. Here what is the h value? I know the h value as half gt square, or I can write as gt square by 2 into reciprocal of r is 1 by u into capital T. 1 by u into capital T, because the range is calculated. The range of the projectile is u into capital T, which is root 2gh I have considered it as, but I have not substitute the total time of flight here. So from which I can cancel out the t square t value, and what I'll remain here is with I'll be having tan beta is equal to so much. So tan beta is equal to, I'll remain with G capital T by 2 into U. If we have seen the previous case here itself, tan theta can be written as GT by U. So if I replace that as tan beta can be written as tan theta divided by 2. So if you are not even provided with the time of flight or initial velocity, you can even just directly calculate the inclination from the point of projection with respect to the point of projection and to the point of striking the ground. The inclination can be equal to the tan of angle of striking the ground by 2. Hope you understood. Support us for more such videos. Thank you very much.